All right, good evening. My name is Don Ficken. I'm with the Library Telescope Task Force, and we've been around for several years promoting the Library Telescope program throughout not only continental USA, but also in Canada and other places. And so we're once again happy to bring you another Facebook Live and Zoom Live program related to the Library Telescope. So if you're not familiar with the Library Telescope, we are in several countries, as you can see from this map. Actually, I think we are at 900 locations. The program's been around since 2008, and not only includes telescopes, but we're now checking out binoculars. And I think we're into something like 6 countries that we know about. And you can go to our website, which is librarytelescope.org, which is at the bottom of this page, and you can find a world map and participating libraries. And there's a number of resources for patrons and libraries to enjoy the telescope and get the program started. We're very proud of our Facebook page. Our Facebook person's not here tonight, but he's got us over 5,000 followers. He has very active postings about astronomy and lots of cool stuff. And our overall goal, of course, is just to grow the program and share best practices. We get together monthly and have webinars like this to get the word out. If you check out our website, one of our members is with the Astronomical League, and we prepare sky maps. It's very common to have sky maps in English, but he also has a Spanish version of that. And he has some other really cool stuff that you can learn about as far as some planets maybe sourced in the placed into the sky somewhere, which is really cool. So if you check the front page of librarytelescope.org, you'll find those maps down on that page, and we also post them to our Facebook page, Library Telescope. We have these webinars pretty much once a month. We did not hold a webinar in November, December, but last month we had about a program on February 14th, actually Valentine's Day, with partnering with a library to launch a library telescope program. Tonight we'll be talking about solar system activities for library telescope nights. This will be a fun way. It's a practical kind of thing that you can add on to your program. And next month we'll have a person from the Lunar and Planetary Institute talking about the International Observe the Moon Tonight. All these are posted out on our website, rather onto YouTube. And if you check out our website, librarytelescope.org, and check the YouTube button at the top, it'll take you to our YouTube page, and you can find a complete library of different videos, everything from starting the library telescope program to viewing them under light polluted skies, 3D printing for the library telescope. There's lots of parts sometimes you need to replace, just a lot of good stuff. Our team's very busy working on things. So tonight's program was Terry Menz. I've known Terry for quite a while. She's with the Riverbend Astronomy Club, and she does a lot of programs. I've watched her in action. She's really terrific. It's a lot of fun. The kind of things she does, it really brings it down to where the children and all families actually have fun. In fact, some of the stuff she'll talk about tonight is actually pretty cool for adults as well. So we will be taking questions at the end of her presentation. We try to keep our overall program about 30 minutes. But you can post those questions to Facebook. In the comments area, if you're on Zoom here with us, you could just post them in the Q&A area, and I'll try to watch for those. And we'll pick those questions up at the end of the presentation. So with that, I'm going to stop sharing and let Terry Menz with the Riverbend Astronomy Club get started. And Terry, it's great to see you.
Hi. Glad to be with you all tonight. Let me go ahead and get my screen shared. All right, can you all see that?
Yeah, we can see it just fine.
Okay, great. Okay. So tonight, I wanted to talk a little bit about solar system activities. So the library telescopes and the binoculars are especially good for viewing the moon and some of the planets. So for this reason, I wanted to bring you a series of activities that provide some depth and some orientation to our solar system for patrons. Now, there's 3 activities that I'm going to talk about tonight, and these provide a foundation for understanding the extreme differences in size of the planets, as well as the various distances between them. Oftentimes that's a confusing concept for children because of when they see the poster on the wall in the classroom, it's everything's kind of not to scale. and they're all on the same map, and they're the same poster, and so they're all aligned and so forth. So by mapping the solar system, we're going to also get an understanding of why we don't see all of the planets every night, and why their relative locations change from from day to day, why their relative locations in the sky change. So this is a display. It comes from the Night Sky Network. Now, this used to be distributed in kits that were sent to participating astronomy clubs for outreach. Now, it's my understanding they no longer distribute these particular kits. However, they did provide on their resources, they provided the ability to make this particular model, and they give you information on at least at that time where you could source these materials. So some of these are just styrofoam balls with balloons pulled over them, or you can make certain pieces out of plastic, or use beads or small pins and so forth. So that information's on the Night Sky Network resource page. So that puts these planets all on scale to each other. One other resource you can use with that or instead of that is this handout. Now, this handout is free both in color or in black and white. You can print a PDF of this, and you can access that on the Night Sky resources page. Now, this model, the reason I like this model per se is that it includes Ceres, and that is an asteroid that is located in the asteroid belt. So you can discuss where in the order of the planets does the asteroid belt come. And it serves as a placeholder to help us convey the concept that the inner planets are all the rocky planets, and then the gas giants are the ones that follow that. So the next 4 planets are those gas giants. And then this model also includes Pluto. Now, the reason this scale model on the left includes Pluto is because it's important to point out that is the inner portion of what we call the Kuiper belt, which runs just along the outside of our solar system. So the overall concept here is that the planets are not this close together, and they're never aligned as shown in this model. So we never see them all in a row. Sometimes we might see part of them in a row, but not all. All right, so this banner here is in scale with the model. So you'll show it shows in the photo a couple of the planets. It shows Jupiter and Earth. Earth is a very tiny, small blue dot on that big sun there. And it's useful to discuss how many of the Jupiters go across the sun. Well, it takes 10 Jupiters to cross the sun and 11 Earths to span the diameter of Jupiter. So in this way, you can kind of give kind of a rough idea of how much bigger the sun is than even the biggest planet in our solar system, and how small our Earth is compared to Jupiter and even to the sun. Oops, excuse me. Went a little too far. Okay. Okay. All right. Let's go to the next slide. Okay, so the next concept that besides the size, we want to talk about the distances between the planets. So the pocket solar system activity uses adding machine tape and markers or pencils. That adding machine tape, by the way, most office supply stores still have adding machine tape. There are some folks that still use it, believe it or not. You can buy it in the small, narrow width or the larger width, either one. And the length, what you're going to do is use a length of tape that's about the width of arms stretched out. So it's approximately a yard or so. But I usually try to do it somewhat by the children's size, but it's better to do it just a little bit bigger if they're a small child. Let's see. Then that length is going to represent the distance between the sun and Pluto. So again, that's the two ends of our solar system. So through a series of folds, the relative distance between these planets can be shown. So I have an example tape that I'll hold up so that the kids can see the names in bold marker, so they can see what I'm writing in case they aren't able to spell yet, or they're just not sure how to spell those names. But I slowly spell each name anyway. And sometimes I'll do it twice just so they can double check themselves. So, like I said, to begin with, you're going to measure that tape out and you're going to have them write sun at one end and Pluto at the other. And then the first fold is basically dividing the solar system in half. So as it shows on the diagram, first fold is right about where we're going to draw a line and write the word Uranus. And we're going to write it right on the tape. Here it shows it underneath, but you can write it right on the tape. And I usually write it on the line, the fold itself. Then you're going to make a second fold. You're going to fold that paper in half again. And those two folds are going to show us where Neptune is, which is between Uranus and Pluto, and then where Saturn is between the sun and Uranus. Now, the next fold, we're going to take the sun and fold it down to Saturn. And that's going to give us the location of Jupiter. So the fourth fold, sun down to Jupiter, so the fourth fold gets the sun down to Jupiter now. So
Hey, Terry, I'm sorry, yes. I actually don't see the video. You're supposed to be playing the video right now?
No, not yet.
Okay, gotcha. Okay, sorry. Yeah.
Pretty quick. It's just going to show the very end. So that sun down to Jupiter, we're going to show one more fold, okay? All right, so now we're going to get to that video that Don said.
Distances. Fold the sun to the asteroid belt and crease it. Next planet in? Right, Mars. Label that. How many more planet orbits do we need to place? Yes, 3 more orbits. Now fold the sun to the orbit of Mars and leave it folded. Fold that section again. Fold that section in half again. Unfold the tape, and you should have 3 creases. Mark Earth on the crease nearest Mars, then Venus, then Mercury closest to the sun. Earth, Venus, Mercury. Have your visitors stretch out the model and take a good look at what they've made. Many people are unaware of how empty the outer solar system really is. There's a reason they call it space, and how close, relatively speaking, the orbits of the inner solar system are. Now all your visitors need to do is roll it up and put it in their pockets.
Okay, I'm going to go over something real quick just to make sure that made sense to everybody. So we did the 2 folds to get the Saturn, Uranus, Neptune, and Pluto, and we already had the sun. Now, we're going to fold the sun down to Saturn. We're going to get Jupiter, and then we fold the sun to Jupiter, And that's where we write the asteroid belt. And then from then on, we're going to do the
Distances.
folds that we see here. So these folds, you have to have the audience pay real close attention, because they're not just folding once like they have been all along. They're folding twice. They're going to fold that sun down to Mars, and then they're going to fold it one more time. And then they'll have the 3 different creases, and they're going to put 3 inner planets there. So here they're going to mark on the 3 folds that they have, M, B, and E. M for Mercury, B for Venus, and E for Earth. Okay? All right. So that was the scale model. So we've talked about size, and we've talked about also the relative distance between the planets. So now, why is it that we don't see all the planets every night? Well, they are obviously going to rotate around the sun at different rates. Now they're all rotating in kind of a plane, kind of a plate, flat air, seemingly flat area, relatively around the sun, but they rotate at different rates. So they orbit around at different rates, and so you're going to see it at different times. So when we look at this diagram, we're going to see some specific things that help us. This is another printout that you can get from the Night Sky Network resources page. Now, on this map, it shows the zodiac constellations surrounding the map that serves as a guideline for those that shows that where we can locate the planets in the night sky. So if you're familiar with the constellations, or you can locate a particular constellation, you can kind of get an idea where in the night sky those the planet's going to be on that particular night. All right, so the orbits around the sun in this diagram only go as far, and let me get my laser pointer here, only go out as far as Saturn. So this circle here is the area of orbit for Saturn. Well, where are we putting the other planets? Well, that's why on this diagram, it just won't fit on the page. So on this diagram, they put another square up here in the corner, and that red arrow is pointing to it, and it shows the other orbits of the planets. And that would be where with the pencil or a pen, you'd mark on there a dot for where those planets are on a particular night. So now how are we going to know that? So we need to look that up. There's a website, and it's you can get to it from this link that's shown on the page, and it's also going to be on the resources we'll see at the end. But you can go to that page, and it's going to give us an idea of where those planets are on a particular night. So let's go there. All right, so if we look up this particular website, oh, and by the way, that website's also listed in the lower left-hand box on this page. All right, so when we go to that web page, and we go to choose the option to look at the solar system, then we will see a page something like this. Now, if you look where the green arrow is pointing, that is where we're going to make sure that we've got the date for the day we're concerned about. So this particular view has the date in there for today, because we have pulled this up today to show you. Once you have the date entered, then you need to decide, do you want it to show you where the planets are based on, or represent the planet with an icon, or with an image. So if you're not familiar with the icons, then you kind of have to go in your head and think about the order and think about which icon you're seeing by where it is, what orbit line it's on. So if you want to see it as an image to make it easier on yourself, you can do that too. And I'll show you that next. The next purple arrow is pointing to the choice you have between the full system or all the planets or just the inner system. So you click on whichever circle tells you want to pick. If you want to pick full system, you click there, and inner system, you click there. Now, once you've made all your choices, you're going to go where the yellow arrow is pointing and click update. That update will update to the choices you have, and voila, you'll get the planets where they're located on the night that you've chosen. Okay, so then that would be translated to that map. So they just copy that over. Now, once you get to the inner planets, it's hard to see them. So let's fix that. Well, first we're going to fix the images. We're going to choose the images and show the same thing, only with just the images. And that makes it a little easier because then you can kind of tell the difference, you know, between Uranus and Jupiter and Saturn and so on. So that's a little bit easier. Okay. So now we're going to change to just the inner system. Now see how much better that is, how you can tell them apart. They're not right on top of one another. So this helps to then translate this image to the paper that the handout up in the upper right hand corner, and you can put the representative locations of the planets there. All right. Okay, so here is a list of all of not only the resources I mentioned, but some other useful resources that you might want to look into. Don showed you some maps from the Astronomical League that are very, very excellent maps. I do like those too. Sky Maps is another choice, and it gives a nice listing of what's visible with the telescope and what's visible with the binoculars. So that's a good one. And then the Stellarium is a planetary program. It's a very robust system that will actually, you can animate it and make it show the planets in rotation. So that's a good one. So I wanted to share these with you, and they're also going to be at the Library Telescope page under librarytelescope.org/solar. So if you choose to investigate some of those. And then this last one is, of course, the one we just talked about. All right, does anybody have any questions? And by the way, you can reach me at outreach@riverbendastro.org and investigate our website. We have some other useful resources and kids' activities on our links page, our resources page, at that website.
Well, Terry, thank you. That's good. So to recap in my mind, you talked about the size of the planets and in relation to each other, right? That was kind of cool.
Mm-hmm.
About how many Jupiters and Saturns and things like that there are compared to the sun. You talked about the distance of things. So that's a nice little adding machine tape thing that you can do. And frankly, it doesn't take many resources at all. Simply
No.
probably a little arm room to stretch out your arms the first time to get you and just be able to have that. And guess what? They even get to take that home, right?
Right.
And then they can work with the location of where things are. And that really helps them understand really orbital dynamics, I guess, if you will, how things really work around the planet. I know that when we go out for outreach, it's very common that people just think that everything's up there at one time. So they want to look at all the planets all at once. And we know from an amateur astronomer point of view, that's just not the way it works. They are not always where you want them to be at a certain time, right? So
that's right.
And sometimes they're really close to each other, and sometimes they're far away. So you're looking for those nice moments like that, right?
Right. Yeah. And these are three concepts that I think all students and all adults really should be familiar with. and understand and have a handle on. And so I like to do these activities, and we do this with a lot of different school groups and Girl Scouts, Boy Scouts, and so on. So, and they've proven to be a very good activity to do. And the one where with the planets and the orbits and where they are in their orbit, I've even done that where I've just I have a big version of that on a banner, and I'll just plot it on there. And even if I don't have that, I will, or, if I don't have the space for that, I can just put it on a representative one of those and talk about that, how you can look that up on a particular night and understand that they're in different places around our sun. So even just having a demonstration sheet is good.
So Terry, I'm kind of curious, how long do you think it takes to do, let's say, the distance, the adding machine tape version of that? Is that something that takes 20 minutes if you have, say, a group of 20 or so? What would be the time you should allot for something like that?
Mm-hmm. Well, there's different ways of, one big factor is the age of the audience. If the audience is very early elementary, it's going to take them a little bit longer because it just takes them a little while to do the writing. A little bit older, they're going to be able to write that out a lot faster. You're not having to spell the planet several different times for them. One of our members had modified the activity a little bit, and I've seen some other versions too. One of our members had printed out labels that we could put on the tape. That's a little tricky because the labels might be too wide, so you have to kind of match that up, the label size to what you're doing, and then trying to find the label on the sheet when you need it, and then put them on in the order that we're doing it, because we're not talking about the planets in order. We're talking about them based on what fold we're on. So that's can add a little bit of time. And then I've seen where people use dots and just the colored dots as representing the planets. And you could do that ahead of time too, just put the first letter of the planet or the first couple of letters of the planet on those dots. And that might help a little bit too, to speed things up, especially for those that can't write, but they still want to get it.
So a question for you. You mentioned Night Sky Network the network resources. Can you explain what the Night Sky Network is that have some of those activities, what that's all about?
Sure. Night Sky Network is a consortium of some different associations like first of all, NASA itself and the Jet Propulsion Lab, JPL. And Astronomical Society of the Pacific is kind of the engine that drives that. So NASA supplies materials and information and so on. But we communicate a lot with the Astronomical Society of the Pacific, and they monitor the website, maintain the website, and their clubs themselves use their resources a lot for communication with each other. But as far as the public, the public can not only benefit from that by finding you can source out your nearest club. So if you don't know about any astronomy clubs in your area, you can go on there and search for based on where you're located, and find a club that's in the Night Sky Network that has the resources like this. That's one thing. The other thing is there's a searchable engine, and that's the link that I gave you on the previous slide. And that way you can look up resources, activities, videos for yourself. They have a YouTube channel where you can pull up a number of different educational videos for the public, as well as just for your own background information as a resource person at a library.
Okay, well, great. Well, it looks like we're coming up on the half hour. Terry, that was really good. So
Thank you.
You remind me of this. I remember this activity from a long time ago, but I haven't used it for a while. But now you've got me excited about using it again. It's so simple to use, really, at the end of the day.
Yeah.
So, really, any
Yeah.
library, no matter what size you are, can actually have this as an indoor activity. Let's say it's raining out or something like that, and you want to learn about the solar system or just activities like that. It's just a very simple thing. And I know that particularly young children love planets. They just love to talk about planets, and this helps them understand how the sizes and distances and where everything's located. And it's a good learning tool, I think. So I really appreciate you sharing that with us. So thank you everybody for joining us tonight. We'll actually capture this webinar into a video and place it on YouTube. It'll be in our library. And next month, I think it's April 15th, we will be talking about International Observe the Moon Night. We have a person from Lunar and Planetary Institute that will talk about how your library can get ready for that. It's actually in the fall, but we want to make sure that you are planning that. The moon is a great target with a library telescope. It's just amazing to look at. And I think you'll enjoy that. So Terry, thank you so much for your time tonight. Great job. And you got me all excited about the adding machine tape thing. I want to go on. I've got some downstairs. I want to go back and do that again. That'll be fun. So yeah. Well, thanks a lot, and have a great evening, everyone.
You're welcome. Thank you. Thanks for inviting me.
Thanks. Bye-bye.
Bye-bye.